Q&As. So I'm hoping to make this session a little bit more. Okay, so I can see, can everyone hear me out? I can see some of you are complaining about the noise and the issue. So is it good from my end?
Ma'am, you are audible, ma'am.
Okay, thank you. Thank you for confirming. Okay, cool. So yeah. Okay. So moving on, a brief introduction about myself. So yeah, hi, this is Roshni Tayal, and I'm working as a lead data scientist at Yum Brands. I have about 4 years of experience in this industry, and yeah, I'm also a MSCS student at University of Texas at Austin right now. And yes, I also work as a data science instructor and mentor at an academy as well as Anma Better. So my expertise generally lies in the area of ML and deep learning. And yeah, I have mentioned some of my hobbies. Eventually there are more, but these two take some priority. Okay. So you can ask your questions anytime while I'm talking. If I can just yeah, I will try to take up as many questions while I'm talking so that I can understand if you are able to get what I am explaining here. Okay, so let's move on. Yeah, as I said, we will be starting with the purpose to understand that why did we choose this topic? Why are we talking about this topic today? So yeah, to start with, why model interpretation is important, right? So first reason I would say is working as a data scientist in the industry and mentoring people in this field, I have seen that data science is still often perceived as a black box, which people think as data science is something like which performs magic or just gives you desired result what you want, right? However, the harsh reality is that without a reasonable understanding of how ML models or data science pipeline works, real world projects rarely succeeds. Right. So let's we can consider any data science project in the real world, and there are typically many aspects to it. We have business aspects to it, we have technical aspects to it, right? And we as a data scientist typically work to build models and provide solutions to the business. However, the business may not know what details we are putting in the model, with what assumptions we are creating the model, right? So but the model that we make for the business while working in the industry is very important to make a lot of decisions for them in the end. Definitely, right? We are working for the industry and we need to make a model which should be useful for the business, right? So there can be such questions like how to trust your model. How is your model giving this result? Like if you are working on a fraud detection model, and if you're saying that person A is fraud due to these features, which your model has been able to capture, how would you explain that why person A has been captured as fraud and why person B with the same feature sets have not been captured as fraudster, right? So to answer these questions, data science practitioners and researchers have been trying for several years now. Coming on the third reason, that bias models have really adverse effects. So while some of you say that if your model is working fine and if it is giving good result, why should we have a question that how does it works, right? Why should we have a question on that? So the reality is that we as a human being, logic and reasoning is something more we adhere to for most of our decisions, right? So this shifting us towards artificial intelligence technology making decisions will no doubt be questioned. For example, like I just gave you an example of a fraud detection system, right? Or let's take an example of a self-driving autonomous car model. So here model understanding and interpretation are of utmost importance, because if your model is biased, let's say if your model has been trained on a biased data set which you have been not careful about while you have been practicing on it, while you have been training on it, it might really affect your model. You will have a biased result as well, right? Okay. Next is, what is model interpretation, right? So model interpretation is to enable fairness, accountability. Fairness, when I say, that means we are not opting for a bias model, right? We want fairness in whatever classification project or whatever project we are working on. Accountability, we should be accountable that how and why our model is giving such a result. And transparency, which will give humans enough confidence to use these models in real world problems which have a lot of impact on business and society, right? So there are whenever a model predicts or finds our insights, it takes certain decisions and choices, right? Model interpretation tries to understand and explain these decisions which your model is taking. That is, it tries to understand what is the result, why is this result, and how have you got this result, right? So mainly we are trying to answer what, why, and how we are getting the results. So the key to model interpretation is transparency. Like we can see the ability to question. More and more questions will keep your models with more of abilities, and the ease of understanding model decisions by humans, right? So I've mentioned three aspects of model interpretation, which you can see here. Like the first is what drives model predictions. So we should have the ability to query our model and find out latent feature interactions to get an idea of which features might be important in the decision making policies of the model, right? This will ensure the fairness in your model when you know which features are really important for your modeling purpose. The second aspect is, why did the model take a certain decision, right? So we should also be able to validate and justify why certain key features were responsible for driving certain decisions taken by a model during predictions, right? So this will ensure the accountability and reliability of your model. Let's come to the third aspect, which is how can we trust model predictions? So we should be able to we should have the functionality to able to evaluate and validate any data point and how a model takes decisions on it, right? So this should be demonstrable and easy to understand for the stakeholders for which you are modeling, actually, that your model works as expected, right? So this will ensure the transparency of your model, right? So the first 2 points, what drives model prediction, will actually ensure the fairness of your model. The second point, why did the model take a certain decision? This question will will ensure the accountability of your model. And the third point, the third aspect, how can we trust model predictions? This will ensure transparency of the model. Okay. Yeah. Let's come to the next slide. So over here, you can see now we are shifting to importance of model interpretation. You can see there are two images to it, which is a very genuine picture, which I've tried to put on. So the first image here tells us that sometimes you do not know if you can trust a machine learning prediction, right? You have created a model with all the genuinity. You have put on the best features that you could take out, the best modeling properties, the best hyper parameters that you could come up with. but you do not know if the result is really trustable or no, right? So if you're selling your model to a doctor, let's say, he will ask you, how can I trust your model that a particular patient has cancer or no, or a particular patient has any particular disease or no, right? The second image over here is telling us that we need to know if we can trust a ML model. Let's say we have built a machine learning model to detect wolves. Okay. And you say that there are certain images which looks like a dog as well, and it is perceiving it as a wolf, right? So they may look good based on the accuracy of your model, but is that enough for us to trust a ML model? The accuracy, is it enough? No, right? So here comes the importance of machine learning model interpretation. So when tackling machine learning problems, we as a data scientist often have a tendency to fixate on model performance metrics like accuracy, precision, and recall, right? So these are the very common performance metrics that we use. So these are important, no doubt. I'm not saying that these metrics are not important or these are not my point is that these metrics are not self-sufficient. We need something more to validate our model, to interpret our model, so to say that yes, our model is correct and it's trustable, right? Matrix only tell a part of the story of a model's predictive decisions. It cannot tell the whole story, right? Over time, the performance of your model might change. There can be many reasons for it. Some new features can be included in your data set, or let's say some new environmental changes, the place where you have deployed your model that could have some versioning problem, or there can be certain problems, right? So in a way, the performance might change due to these faults, due to these assumptions that you have taken. Hence, it is very important for us to understand what drives a model to take certain decisions. Okay. Second, would you be satisfied with the model just predicting and taking decisions? Like they are just telling you what is the decision, what is the result. Like if a person has cancer or diabetes and your model is just saying that this person X has cancer and this person Y has diabetes, would you be satisfied with just with that result? No, right? Maybe not. We are not satisfied with that. We might prefer it more if we could know more about the model's decision process, the why and how these decisions were taken. Right? This gives us more transparency into why the model makes certain decisions, what might go wrong in certain scenarios, and over time, it helps us build a certain amount of trust in these machine learning models. Okay. So whether humans are directly using machine learning classifiers as tools or we are deploying models within other products, our vital concern is always there that if the users do not trust our model or a prediction, they will not use it. Okay. So no one will use your model if you're not able to build trust on your model, right? Especially the customers. Cool. Now comes the scope of model interpretation. Okay, I can see a lot of questions will take at the end. Let me just complete some of these slides and then we'll try to take up your questions because these slides may answer your questions, right? Eventually. So let's progress right now. Okay, coming to the scope of model interpretation. Now the question is, how do we define the scope and boundaries of interpretability? Some useful aspects can be, like we discussed, it can be transparency, accountability, fairness of our model. So with this, two approach comes into mind. One is global interpretation and the other is local interpretation. So these are clear ways to define the scope of model interpretation. Like you can see in the diagram, global interpretation or global interpretability is all about being able to explain and understand model decisions based on conditional interaction between the dependent variable and the independent variable, right? So the response variables that you have and the predictors, the independent variable that you have on the complete data set. Okay, so in global interpretation, as the name suggests, we take the whole data set, the complete data set. So global interpretation is all about trying to understand how does the model make predictions and how do subsets of the model influence model decisions, right? To comprehend and interpret the whole model at once, we need global interpretation. Okay. Now, local interpretation is just the opposite of it. It just, the difference lies in global interpretation, we take the whole data set, but in local interpretation, we just take a single prediction. Okay. So in local interpretation is all about being able to explain and understand model decisions based on conditional interaction between the response variable and the independent features with respect to a single data point. Okay, like you can see in the diagram, global interpretation has been marked with this green dots because we are talking about the complete data set. And the local interpretation, we are talking about a particular feature, a particular data point. Okay, so local interpretation is all about trying to understand why did the model made such specific decisions for a single instance. Or you can say, why did the model make specific decisions for a group of instances? So one good thing is that in local interpretation, we do not care about the inherent structure, the underlying assumptions that we have taken while building the model, or you can say we treat it as a black box. Okay. So let's come to some of the traditional techniques for interpretation, which is existing right now. So these techniques have been existing for a long time now. As we know, model interpretation now, what is model interpretation? We are clear on it, that it is to find out ways to understand model decision-making policies better. This is to enable fairness, accountability, and the third word is transparency, which will give us as humans or stakeholders or data scientists enough confidence to use these models in real world problems, which will indirectly create a lot of impact to business and society. Right. So there are techniques which have existed for a long time now, which can be used to understand and interpret models in a better way. So there are two major categories which we have here. So the first is exploratory analysis and the visualization technique. Second is model performance evaluation matrix. Exploratory analysis and visualization techniques like clustering, dimensionality reduction, the PCA method that we might have heard a lot about it. Then we have model performance evaluation matrix. So these matrix, like in case of if we are using supervised classification algorithm, we have precision, recall, accuracy, ROC curve, AUC curve. And of course, for regression models, we have R square, root mean square, error, mean absolute error. We can have others as well. Okay. So with this, let's jump onto our first traditional approach, which is exploratory analysis. Okay. Yeah. With this, let's jump to our first technique, which is exploratory analysis. Yeah. So the idea of exploratory analysis is actually not new. We have this already. Oh, just give me a minute. So this idea of exploratory analysis is not something entirely new. For years now, we have been using these methods like data visualization. It is one of the most effective tools for getting the insights from your data. Some of these techniques can help us in identifying key features and meaningful representations from our data, which actually gives an indication of what might be influential for a model to take decisions in human interpretable form. Okay, so there are like in the image that you can see, we have this iris data set. This is a very famous diagram which is already present all over the internet. So this is actually after using PCA on this data set, which we can see here, proper clustered organization of 3 different types of classification category that we had in the data. So the first is dimensionality reduction. In this exploratory analysis, we have different methods in it, like PCA. We have latent semantic indexing. We have other methods for this purpose, which is TSNE, which is also called as T-distributed stochastic neighbor embedding. And then we have clustering approach as well. Coming to the model evaluation matrix. So we have a lot of model performance evaluation matrix existing right now. And these model performance evaluation is a key step in any data science lifecycle for choosing the best model, right? So you have worked on your data, you have created a model, but what will you use to evaluate your model? So there comes in the role of model evaluation matrix, which will help gauge the performance of your model. Okay, so this basically enables us to see how well our models are performing, comparing various performance matrix across models that you have created, across multiple models that you have created, and choose the best model out of it. This also helps us to actually choose the best hyperparameters, to optimize hyperparameters for our model. So we can say that it helps us to tune and optimize the best hyperparameters that we want to use for our model for the best results. And of course, there are certain standard evaluation matrix which already exist, like some of them we already mentioned. You can see a very sample result of a model where you can see different matrix that are there. For supervised learning classification problem, our objective is to provide a discrete categorical response variable, right? So in this case, a confusion matrix is extremely important, extremely useful, because it helps us to derive a whole bunch of useful matrix like accuracy, precision recall, F1 score, right? And we also have ROC and AOC curve, which is actually very useful and commonly used in classification problems. It basically helps you try to balance the true positive rate and the false positive rate. Then we have regression algorithms. So for regression algorithms, we can use standard matrix like the coefficient of determination, which is R square. Then we have RMSE score, which is root mean square error. We have mean square error as well, MSE score, and then we have mean absolute error as well, right? So there is a proper illustration of all these matrices out there over the internet, and you can read about them in detail. We have formulas around it, right? So it's just the names that I'm just taking out right now. Then in case of unsupervised learning, so obviously there are 2 categories of ML models, supervised and unsupervised. In unsupervised learning, we have the clustering models. So for unsupervised learning problems, we have the matrix like Stillhoward coefficient, homogeneity. These will help you gauge the performance of your model. Okay. With this, let's come to limitations, right? So we discussed about the traditional approach to model interpretation, but we have certain limitations to them as well. So the techniques we discussed are definitely helpful in trying to understand more about our data, features, as well as which models might be effective. However, they are quite limiting in terms of trying to understand human interpretable ways of how a model works, right? Like we also discussed earlier. In the real world, a model's performance often decreases and increases over time after deployment. It can be dependent on multiple instances like the environmental changes, the place where you have deployed your model, the additions in your data points. There are some new features, the variability in data features, some added constraints, some noise introduction. So there can be many factors due to which your model gets affected with time, right? But with these changes, simply retraining a model on the same feature set will not be sufficient, and hence we need to constantly check for how important the features that we are taking are in deciding model predictions, right? And how well they might be working on new data points. So, as already said, metrics do not help us justify the true story of a model's prediction decisions, right? These traditional forms of model interpretation might be easy for a data scientist to understand, but since they are quite theoretical and holds a lot of mathematics inside them, it is quite tough for the stakeholders, for the non-technical person to understand our model, right? And the business stakeholders for which you are preparing the model are there to decide the success criteria of your model based on a project, based on these matrix alone, right? So just telling the business that you have created a model which has 80 to 90% accuracy is not sufficient information for them to start trusting your model when you have deployed in real world, right? So we need human interpretable interpretations of a model's decision so that we can explain with proper and intuitive inputs and outputs which could be easily shared with peers, whether it be analysts, managers, data scientists, other data engineering folks, with whom you are sharing the results, right? This might help facilitate not only better communication and collaboration, but it might also enable businesses to make more confident decisions in this respect, right? So these exploratory data analysis as well as the evaluation matrix are not self-sufficient to justify the model interpretation. So we have a lot of new interpretation techniques out there as well. Keeping these points in mind, we have a lot of techniques. The first is using interpretable models. Then we have feature importance, global surrogate models, and then we have line method, which is a very novel method. Let's quickly jump on to the interpretable models. So this is the first new technique of model interpretation, which is using interpretable models. So what do we mean by interpretable models here? When we say interpretable models, we are talking about the easiest models that exist there, right? So the easiest model, when we say, it's the model which are linear in nature, like linear regression, logistic regression, tree-based models. These parametric models we are talking about. So a way to categorize these models based on major capabilities. Like we have we judge the linearity. We check the linearity of the model. So how can we say that a model is interpretable? First, you need to check on its linearity, right? If we have a linear model, then the association between the features that you have taken and the target variable is modeled linearly, right? Then we have monotonicity. So a monotonic model, why a monotonicity is considered? So a monotonic model ensures that the relationship between your feature and the target outcome is always in one consistent direction, right? So it helps make your model more interpretable than interaction, right? So you can have more of interaction features in your model. You can have more um, non-linearity to your model with some of the feature engineering steps. So yeah, so these three are there, and you can see that there are some of the algorithms against which there are linearity, monotonicity, and interaction have been defined, and their specific task which they do. So you can accordingly decide which of these models are more interpretable. So this is one of the method where you can use the interpretable model for your business, so that you can easily say that why this particular decision has been taken by a model. Okay, let's move on. Then we have feature importance. So the second technique is the feature importance. So feature importance is a very generic term for knowing the degree to which our predictive model relies on a particular feature. Typically, features importance is, I mean, we discuss this features importance in the model's prediction. So whenever there is an increase in the model's prediction error after we permute or we just change the features values, then we talk about feature importance in context of model interpretation. So over here, like you can see, I've just attached a sample picture here. Like you can see, there are two features which are there: age and education number, which are the top two features. And like you can see, age is the topmost feature, where it is responsible for model predictions changing by an average of 14.5% on permuting the values of the age feature. So what we do here is, in short, we measure features importance by calculating the increase of the model's prediction error after changing the feature. Okay. A feature is said to be important if changing its values increases the model error, because the model rely on the feature for the prediction. Okay. A feature is said to be unimportant if changing its values keeps the model error unchanged. Okay, so if the model error increases, then you will say that that a feature is important. If it does not changes, if it remains unchanged, then you will say that the feature is unimportant. Okay, so this is how we decide how a feature is important for us. Then we have global surrogate models. So in this, basically, we see various ways. So we have till now seen various ways to interpret machine learning models with feature importance, the more interpretable models, right? But is there a way to build interpretable approximation of really complex models? So is there a way that if we are using a complex model, which is quite possible in the real world, we can interpret it? So we have global surrogate models for that purpose. What a global surrogate model is: an interpretable model that is basically trained to approximate the predictions of a black box model, which can essentially be any model, regardless of its complexity or training algorithm. Okay. So in case of, while we are using global surrogate models, we approximate a more, so typically we use a more interpretable surrogate model based on our base model, which is treated as a black box model. So I will just go through the steps, which is what you can see, and this will help you to imagine what are the steps we follow in case of global surrogate models in order to create global surrogate models for our model interpretation. right? So the first step is you choose a data set. It can be the same data set that you use for training the black box model, or a new data set from the same distribution. Okay. Then the data set, then for the chosen data set that you have, you get the predictions of your base black box model. Then you choose an interpretable surrogate model. So it will be mostly the linear models, which are more linear, which have monotonicity and more interaction. So like linear models, decision tree based models, knife based model. So you will choose an interpretable model. Then we will train the interpretable model on the data set and its predictions. Okay. Then we are able to create a surrogate model, and then we measure how well the surrogate model replicates the prediction of the black box model, right? So you already had the predictions from your black box model, which was your base model, and then you just compare or measure that how well the surrogate model is able to replicate. Then we finally just interpret our surrogate model's results. Then we have LIME approach. So the full form of LIME is a little bit complex. It's local interpretable model agnostic interpretation. So LIME models are based on local surrogate models. Before this, we studied about global surrogate models. This is based on local surrogate models. These models are interpretable models like a linear model or decision tree, which are learned on the prediction of the original black box model. But instead of trying to fit a global surrogate model here, LIME model will focus on fitting local surrogate models to explain why single predictions were made. Okay, so what is the meaning of local surrogate model that I'm talking about? Whenever I mention the term local here, we are talking about single prediction. We are talking about one of the prediction that we are getting from the model. So we have steps here as well, a little bit changed, but yeah, first we choose the instance of, where we want to have an explanation of the prediction of our black box model, which we have created. Then we change the data set a little and get the predictions, black box predictions. Then we weight the new samples by their so with the help of distance, we weight the new samples. Then of course we fit a weighted interpretable surrogate model, and then we explain the predictions that we have from these local models. So of course a lot of steps are there which we cannot talk about in detail. So I'm just trying to give you a hint of what all methods we have and what all steps we follow in these techniques. Of course, we can have a detailed session on, it will take time to understand each and every method and its hands-on implementation. So let's try to see a very simple example of how we can interpret a model in real life in a simple data set. So there are certain frameworks for model interpretation. There are 3 existing frameworks which is already there. First is LE5, then we have Skater, and then we have SHAP. So Skater is, so we all these are open source frameworks that we can use for model interpretation, and they all help us to interpret the model to for model interpretation for all forms of model to help us build an interpretable machine learning system, which is often needed for real world use cases. Okay. Out of these, I would like to highlight LE5 is a Python package which actually is very easiest to use out of the three frameworks, and it involves, if you will look at the documentation of it, you will realize that it involves minimal reading of the documentation as well for LE5. So of course, as the first step, you need to load the libraries that are there. Libraries you have, you can load. First is I'm just trying to load all the libraries which are there. So SHAP here stands for Shapley Additive Explanations. We definitely have the details over the internet, but yeah, it requires JavaScript to display the plots. Okay. Next is loading the data set. So once you have loaded the libraries, you need to load the data set. And I have, for example, taken census income data set, which is also known as the adult dataset. This is easily available in UCI ML repository. The objective of this dataset is we need to predict whether income of adults exceeds $50,000 per year based on census data. So this dataset is also known as census income data. So I'm using SHAP here to get the model, to load the data, because SHAP provides us an already cleaned up version of this data set. So you can see we have the output features and the code as well. The code is there to load the data, and we have the output features as well. So the features that we have here, let me just walk through them. It will help you to understand the data that we are talking about. The first is age. Age is a continuous feature here. It is definitely representing the age of the person, the adult that we are talking about. Then we have work class. So this is a categorical feature which is representing the nature of working class category. So whether the person works in private job, self-employed, federal government job, local government job, or state government job. So all these categories are there. Then we have education num. So this is again a categorical variable, and this is the numeric representation of educational qualification. And in this data set, it is ranging from 1 to 16. So we have several educational qualification here, like bachelor's, some college, 11th grade, 7th to 8th class pass candidates, 12th pass candidates, master's pass candidates. So yeah, corresponding to that, we have the ranges from 1 to 16. Then is marital status. So this is again a categorical feature representing the marital status of the person. Is he divorced? Is he never married, separated, widowed? There are various examples in it, categories in it. Then we have occupation. This is again a categorical feature representing the type of profession or the job of the person. Whether he's in tech support, craft repair, other service, right? Then of course, relationship. So this is again a categorical feature representing the relationship status of the person. Does he have a wife, own child, husband, not in family, or relative, unmarried, whatever. Then we have race. This is again a categorical feature representing the race of the person: white, Asian, Black, Eskimo. Then of course, sex, representing the gender of the person. Capital gain, this is again a continuous variable, the total capital gain for the person. Capital loss, so this is the continuous variable which represents the total capital loss for the person, right? So capital gain and capital loss are there. Then hours per week, continuous variable, which represents total hours spent working per week. Okay. Then we have country. So this is a categorical variable where we have the country where the person is residing. Income label, so again, a categorical feature, and this is your predictor. Actually, this is your independent variable, your class label. So the class label column is the one we are predicting here. So okay, so we cannot see in this picture here, but yeah, it's there. Income label is there. It's only the training data that the dependent independent features that you can see here, right? So income label is there where we have incomes. So if the income is less than equal to $50,000 per year, then we have the label as false, else it is true. Okay, so we have a total of 12 features in our data, and our objective was to predict if the income of a person will be more than $50,000 per year or less than $50,000 per year. Okay, so we are building and interpreting a classification model for this. Okay, so here I just wanted to take out the count of the labels that we have. For the false category, which is less than the $50,000 and greater than $50,000, how many instances do we have? And definitely we can see some class imbalances there. So like you can see here, zero is representing as false category. It has 24,720 instances and 7,841 instances for the greater than $50,000 income people. So definitely some class imbalance, which is expected. Yeah. Now let's come to the feature engineering, where we convert the categorical columns with string values to numeric representations. So yeah, with this you see we are able to convert all the categorical columns to string to the numeric representation. You can see there are no such column which has the categorical value now. Then, of course, we moved on to train test split. So for any machine learning model, we always need train and test data sets. We will be building the model on the train data set and test the performance on the test data set as usual. So here you can see we have I've written the shape of the data, which is there. Like for training, we have 22,000 instances approximately. And for testing, we have 10,000 instances, right? And here, one more thing, that we are maintaining two data sets. This is one of the data set that you can see in the output section, the data frame that you can see here. So this data set is actually has encoded categorical values, right? So when I say encoded categorical values, you see we have converted the categorical values to numeric here. And the other data set that is there is this, where we have non-encoded data, right? So we have maintained two data sets, so we can train with the encoded data set, but use the original data set as needed later on for model interpretation, right? So this was what I was talking about, that we take the predictions from the black box model and then we just match with the other surrogate model that we are talking about. Okay. Now, training the model and making predictions. So yeah, here we are just training and building a basic boosting classification model on our training data using the XGBoost framework. And yeah, we then use the trained model to make predictions on the test data set. Like you can see, we have the predictions already in this array form. Then, of course, the model evaluation. So I just used this model evaluation utils model to get the model performance matrix here, which is actually using scikit-learn in the backend to give us the results. right? So we have the results here, and with this, interpretation comes into picture, right? So we have, like we discussed, we have default model interpretation methods. By default, it is difficult to gauge on specific model interpretation methods out of the box. Here, we have tried to use the LE5 framework to get the data. So here in this slide, you can see that I've used the show weights method just to see that what are the weights for the different features that are there, right? So here, I would say that one of the best way to explain model prediction decisions to either a technical or a more business oriented individual is to examine individual data point predictions, right? And LE5 does this by showing weights for each feature, depicting how influential it might have been in contributing to the final prediction decision across the XGBoost model that we used. Right, so yeah. Now we are predicting with LE5. So what we are doing here is we are just trying to predict when a person's income is less than equal to $50,000 and when a person's income is greater than $50,000. So in both of the cases, both of the charts that you can see here in the output section, you can see that the most influential feature in the first chart, if you see by the value, right? It's country, it's hours per week, age, and education now, right? It's occupation. Yeah, occupation is also there, but yeah, it's very less. And when we do the prediction on a person's income greater than $50,000, we can see the most influential features are the same, which was there for greater than equal to for less than equal to $50,000 instances, right? So for both the classes, we can see there are the same features, the same influential features. So yeah, it's definitely interesting to see how similar features are playing an influential role in explaining model prediction decisions for both of our labels, right? So yeah, with this, we come to an end. And yeah, sorry, I took a lot of your time. I'm just in for question answers that we have now. Yeah.
Ma'am, just before we proceed to Q&A, thanks a lot on behalf of Analytics Vidya. I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. Right. And I hope you guys have filled the feedback form. If not, I request you guys to please fill in the feedback poll, as it helps us to conduct more such sessions. Now, ma'am, you can please proceed to the Q&A.
Okay. Okay, so the first question that just a minute. Yeah, I can see a question that I'm learning data analysis through various YouTube channel and free certificate course as to get into a job as a fresher. How depth should I know, and like how the resume should be? Okay, so this has been asked by an anonymous attendee. Okay, so definitely you're trying to learn data analyst skills, and that is what. So first of all, you should be clear with the skills that you are trying to acquire, and you should be clear with the difference between data analyst role, data engineering role, and of course data scientist role, right? So in case of data analyst, you definitely have to go through these machine learning basics, the SQL role, the SQL language, and more of the visualization tools like Power BI, Tableau. You can have the skills for, you can include more projects in the section. The Excel skill is also very important for a data analyst, and definitely EDA, the data visualization skills are very important. right? So if you ask me that how should your resume would be, I would prefer, if I am watching a resume for a fresher, it should have basically all the not all the, but should have major skills related to a data analyst, right? So you should include more of the projects that you have worked on, showcase your projects, because being a fresher, definitely your projects are the ones that can save you out, right? It can illustrate your working experience. So yeah, I would say work on more of the case study questions, include more of projects, include more of the links to your notebooks that you are creating while you're coding, and of course the Python. Your Python should be good for the EDA. Right. So I guess I answered this question. Cool. Okay, I have two same questions from two different people. I can just click on one and answer live. So yeah, the question is that why to maintain different encoded and non-encoded data sets for the test, train, and model interpretation tasks represent respectively. So I would say, like, we have been discussing about the different new techniques for model interpretation, right? Therein we saw that we maintain two different data sets, where in one data set we get the prediction of the modeling approach that we are following, right? And the other data set we keep separate just to compare the result of our black box model, the modeling technique that we are applying, so that we can compare and we can interpret our model in a better way, right? So I hope I answered your question. Okay. Linked, there are less job in data analytics where to apply data analytics role. So you have different job portals for applying to the job. Like you have, I wouldn't say, I wouldn't name any as such portals, but I need you to search through it. Like you have Noki.com, you have LinkedIn, you have other websites as well. And there are few websites as well which provides the free resume pattern for you to make, right? So I would suggest you going through them, make a good resume and apply in those portals. Try to be active as much as possible, and definitely you will get a good role, good opportunity. I am from automotive. Should I get entry on fresher basis? I am enhancing skills. Definitely. If you are from a non-tech background, I can totally understand. It's now when you are trying to inherit these technical skills, it totally makes sense. Um, if you are trying to get an entry on fresher basis, I would suggest just focus more on projects. It will help you a lot. It will help you out, and also enhance your skills as well. Thank you. Okay. Yeah. What are the interview questions asked about model interpretation and evaluation, asked by Abbas? So definitely there are a lot of interview questions that can be asked here, but more to the interview questions, I would say this is more pertaining to your skill for interpreting your model, which you create on a daily basis as a data science scientist or data science practitioner. So I would say, um, if you are really interested in knowing about interview questions related to it, just try to get to know about the basic new techniques that we follow in case of data interpretation. That will help you out. Nothing other than that. and it's more of implementation that you should know. What is the x-axis value and feature importance? So definitely I get it, Siva, you were trying to ask for the feature importance graph that we saw, and therein we saw that the two features were of utmost importance. One I remember is age, another was education. So these two features are definitely so in the x-axis we were trying to keep the value of the model error. So the concept behind feature importance was that if you permute a feature, then your model error performance should also increase. If it increases, your feature is important, otherwise, no. Okay. So there are a lot of questions, but do we have more time here?
Ma'am, we can extend 10 more minutes.
Okay. Cool. Now the question is, which is better company, career portals or job portals like Naukri? Definitely, you cannot rely on one job portal here. I would say you should be very active while you are in the application stage. Just try to make a good resume and try to have your application active in multiple portals. There are job portals out there which are not as famous as Naukri.com, but they are definitely good. You can get good opportunities through them as well. So I would say just be active in all those portals. And of course, when I say being active, it means not, it doesn't mean you should take a premium membership of them. It is not required. You should just be active in terms of updating your resume, updating your skill sets in your resume. That's it. To answer your question, Pankaj, how can I get internship in data science as a fresher? Okay. So as a fresher, getting internships are quite beneficial because with that, you are able to get an exposure to the industry work that you need to do in industry, the real world projects that you need to work on, and of course, the experience that actually matters. So in order to get an internship, just reach out to multiple people, take the advantage of your network, try to build your network over LinkedIn. LinkedIn is a good website for this, good portal for this. So try to enhance your connection and reach out to multiple people with your work and resume. You will definitely get an internship. And yes, of course, apply for the active job opportunities if we have. Okay, rather than algorithm, what are Python coding part we need to focus on for AI, ML, DL, NLP? Okay. Okay. So you're asking that what are the Python coding part that you need to focus apart from artificial intelligence, machine learning, deep learning, and NLP, rather than the algorithms? Yeah. So absolutely, it's not just the algorithms that you need to be good for in terms of coding in Python. There are a lot of other things like data engineering, feature engineering, data analysis, where you need to be good in handling the data. Not only, I mean, Python, but you can also learn SQL for this, as well as there are other places where you like we just saw the whole life cycle of a model for coding, right? For building a model. Then the Deployment part comes into picture where you need to be good in Python coding, but it definitely needs, I mean, you need to answer that what part are you focusing on? What part is essential for you right now? So yeah. Okay. Lime is not clear. Could you please explain it again? So I can explain it to you here. So Lime we studied after global surrogate model. You can just remember like this. In case of global surrogate model, what we were doing is we were focusing on the complete data. Okay. But in case of Lime, we are focusing on a local surrogate model. That is, we are focusing on a single prediction that we get in case of Lime, right? But in case of global surrogate model, we focus on the complete data prediction that we have. Okay, so if you will compare with the global surrogate models, you will be able to understand Lime more clearly. Definitely, you can refer to more of online articles for reading through this. Cool. Okay. The a very generic question here, which I feel I should answer. Why interpretability when we have many models, each for every situation? I okay. So I hope you have got some answer to it, but definitely just to fill in, um, interpretability is really important. You have a lot of models already out there for each and every situation, for each and every modeling purpose, right? But interpretation is important on top of your modeling approach, right? You have modeled, you have created a model, you have your results, but you will not be able to validate your model, right? So interpretability comes there. After you have created your model, you need to interpret your model so that you can justify that yes, if it is saying that a particular person has a disease, why it is saying so, how it is saying so, right? You need to justify that. Right? That is why interpretability comes into picture. Okay. We have a lot of question. Let me just take up the last question. Um, okay, so can you explain when to prefer or use precision and recall? So definitely they both are different matrix that we use in case of classification model. Precision is more of related to measure of quality, and recall is more related to measure of quantity. So you can just relate to it with the different use cases. Higher precision will mean that an algorithm will return um, more relevant results, and high recall will mean that an algorithm will return most of the relevant results. Okay, so definitely it is crucial topic in machine learning. To answer your question, Shankar, how to decide which features are important? So definitely we just saw the method, right? I tried to explain a simple example on the census income data as well. That how do we decide which features are important? We are trying to apply the same scenario to the different labels that we have, and we were able to get the same instances, same features highlighted in both the cases, right? So this helped us to get the most important features that are there for our data, and hence justify that how our results are coming on the basis of those features. It's so yes, I think we covered this in the deck. Okay, so yeah.
All right. Thanks a lot, ma'am. It was a wonderful session. And I hope everyone has filled in the feedback poll. And we'll be back with another session on the data on 28th December. The link is in the chat section. Till then, bye-bye and keep learning.
Thank you, everyone.